You starting something? What's up? All right, wait a minute. Does that work? Yes, sort of. Like that? Feeling stable? More than me? Oh, what's your name again? Ah. Come on up here. Are you Chris? Yeah. Okay. Is that all you? Yes. Okay. Oh. I don't know. What's your name?
Yair.
Do it again?
Yair.
Oh, yeah.
Last name?
You just forgot the little
Oh, Celis?
one fourth right here.
Celis?
Yes.
Yeah.
It's just,
Did you take the quiz?
oh, no, I didn't.
Oh, well, there you go.
Yeah.
Here, you can have a copy of it. Here. But just for yourself, so you can see what it was. Oh, all right, is that everybody? As I stand here, I'm pretty sure I did not curve it, but as I stand here, I can't remember. I'm pretty sure I did. I had several hundreds, so I don't think I curved it. The average was good, so I mean, yeah, I probably left it. So I have a question on the floor. Let's see. I'm going to pick it up and put it here. What was it again? X squared minus 2x? Integral of x squared minus 2x, like that? Okay. Do you know which homework problem that was?
It was like 30-something.
See if you could find it.
Yes.
So guys, before I do this, are there any questions on that quiz? I kind of hear murmurs. Are you guys, any questions from the quiz?
Oh, that's good.
Okay.
33.
Like you? Okay. Okay. Yes.
It was 33.
In which section?
7.3.
All right. So everybody playing along. This is 7-3-33.
I'm very used to speaking.
All right, guys. If you were here about 4 minutes ago, then you know what kind of problem this is. Anybody? I know I wasn't alone 4 minutes ago. We did a problem that was harder than this, but it was the same idea as what we need to use here. Yeah, this is one way to do this problem. I can complete the square. Yes? It can't be u sub directly because there's nothing outside to be du. Okay. So if I just figure out what to add and subtract, and again, we already did this one, yeah? Is that okay? I mean, so half of negative 2 is negative 1 squared is 1, so I add 1, I subtract 1, and now I've got that. Now, if that wasn't there, that's just a straight up trig sub, right? All right, same thing there. That's just a straight up trig sub.
Right.
Now, real quick, just to show you, dear God, you don't have to do this. All right, look. If I had this, can you guys tell me what trig sub you would do? I'm going to show you 3 things. Here's the first thing. If I had this, pretend like you could read that. If I had this, what trig sub would you use? Secant, because it's function squared minus 1. Secant squared minus 1 is an identity. Slowly, more and more people are understanding what I mean by that. You have to know your identities, and then the form of the integral tells you which identity to use. It's not a guess. It's not, let me just hope and pray I picked the right one. So x equals secant theta, yes? Is that cool? So over here, first level you could do is, what do I have squared? X minus 1. So not x equals secant theta, but x minus 1 equals secant. If you don't like that shit, you could do a u sub. What do I not like? I don't like that that's 2 terms instead of 1, yes? So you don't have to do this. Dear God, you don't have to do this. But if you let u equal x minus 1, what's du?
1.
No.
Wait.
Dx. So, I mean, this is kind of a silly u sub to make, but it's the safest u sub to ever make. When you have a linear slope 1 piece that you're like, man, I wish that was 1 term instead of 2. You could do it all the time. And then this integral just becomes this, which looks exactly like this did. You didn't really do anything fundamental when you did that use. You didn't change the form. You just made it easier to look at. Do you have to do u sub? No. Can you, if you like looking at this more than you like looking at this? Shit, yeah. Shit, yeah. But you just have like 2 layers to go back now at the end. Yes? Does that make any sense? I'm sorry. I know some of you guys are like thinking to yourself, does that make any sense? Never. Okay. Shit. Let me do this real quick before I forget.
I think it makes sense, but then when we see the problem, we don't think about doing that.
Oh yeah, well, start doing that. No, all right. Let me see if I can say this. Do you start to understand, when you first learn completing the square, it feels like a bogus thing. Because you learn completing the square, and then you learn quadratic formula, and you're like, why would I ever do completing the square? Are you guys, does anyone remember these days? You guys remember this? You learn completing the square, you do a few problems, then you prove quadratic formula, and you're like, why the shit would I ever do completing the square? I just plug shit into quadratic formula. When I teach completing the square, I try to tell them, this is only one tiny little application of completing the square. It is crazy useful in all places. Here's one place. I have my x shit not like terms, I can't put them together. You with me? When I see that, when I see x squared and there's other shit with it, I'm like, dude, I wish that was together with just one x. So that's the whole point of completing a square. It gets all my x shit together when they're not like terms. Is all my x shit now in one term? Yes, that's the power of completing a square. You guys see that? So, I don't want you to try to have this like 28-point thing you go through and you memorize it. That's not the point. Just realize when you see x squared with other x pieces, one thing you should consider is completing the square. Right? Is there potentially other ways to do this problem? Hell yeah. Did anyone do this problem a different way? If not, it's okay, because I mean the textbook method is fine. And it's in the trig subs place, so you should try probably do trig sub. Okay. Beautiful, okay. Anything else from homework stuff? Or even from the quiz? Did anyone else not get the quiz back yet? Did everybody get the quiz back? Okay. Oh, let's
You were on the right track there. Change your mind.
And then I sprinted into the woods. I know I changed the sign. I don't like that.
Everybody else good? Oh, what's up? Sorry? Yes.
Can you do 7-3, 20?
Is everybody good with this one? Especially the person that asked it? Okay. Which one again, I'm sorry?
48 on 7.3.
7-3, 48.
The one with lambda epsilon.
Ooh, yeah, look at that. Ooh. That is so, okay, I'm gonna be very creepy for a second. That is so yummy. Look at that. Permeability of space. I mean, come on. Is that permittivity? That's permittivity. Mu is permeability. None of that matters. Do you have to know physics all of a sudden to do this? No. What is the only variable in there? X. Everything else is a number. Yes? You see that? They are weird looking numbers. But I don't give a shit. No, you might give a shit, but I don't. All of this is a number. That whole thing right there is a number. What could you do if you wanted to? Take it out, right? And then the other stuff is the stuff that actually is involved, is involving the variable. Yes? You guys see what I'm saying? So don't let, like, constants, whatever form they take, you can't let them bother you. If they're bothering you, get rid of them. You're bothering me, get out of here. And then what you're left with is 1 over x squared plus b squared to the 3/2 power. And what is that screaming to have happen? And like, what do you mean? Integrals can scream now? This is horrifying. Yes? Okay, let me rewrite this. Let's do the first couple steps. I'm not going to do the whole damn thing. But, where'd it go? So if I pull out lambda b over 4 pi epsilon naught, it's got some limits, who cares? 1 over x squared plus b squared to the 3/2 power dx. Oops. That's where we end up, right? If I pull all that constant stuff out of the way? Is there any simplification I can do? What could I do? Careful. I can't distribute it 3/2, right? Because it's addition. It doesn't go across. It's based on multiplication. There's no simplification I can do. You guys see that? Well, I'm open. I don't know everything. Maybe there is. I might say no. So then what do you think I could potentially use then? What form is my variable involved in? What form is it? X squared plus b squared, which is a tangent sub. Yes? Okay. In fact, what section is this in?
7.3.
Holy shit! All right. So when in doubt, look at the title of the section. But that doesn't mean you have to use that. Some of the problems I would argue you don't have to use trig sub in some of the problems. But most of them should probably use trig sub. Is everybody with me? What the shit would it be? You said tangent, but be more specific. X equals b tangent. Right? If it was 9, it'd be 3. If it was 16, it's 4. If it's b squared, it's b. Because that's what we do. Take the square root of the constant piece, right? X equals b tangent theta dx. Plug it all in. Right? Maybe? Is that okay? I mean, does that give you a place to start if you weren't even sure what to do? Whoever asked the question, is that not where the problem was? Or can you go further now? I forgot who asked. Could you go further now, or okay. I don't blame you if all the lambda and all the crap. You're like, what the shit does this guy want? This is constants. Get them out there. How do I know it's a constant? Freaking dx, right? So I know what the variable is. So any multipliers that aren't x, I can just take them out. Maybe. And if you really wanted to, you can call all this shit. What's your favorite letter that's not already used? S, you can call. Oh, S is not my favorite letter.
Oh, okay.
It looks like a 5 if I'm not careful. See there? Doesn't it look like a 5? What can I do?
Just write it in person.
I'm going to call this
Q.
Q. Yes. I replace all that shit with Q. Because what is this? What's the value of this? Do you know? No. What do we do in math when we don't know something? We call it a letter. There you go. As long as at the end, does everybody really understand what I'm saying? You don't have to do this Q shit. You don't have to replace that. You don't. But if it really gets in your way, call it Q. It is one number. Yes? If I knew the values of all this shit, it's a number. It ain't 7, but it's a number. And if I don't know what it is, I can call it Q if I want to. And then it just looks cleaner as you do it. If it's getting in your way, just replace it. We're humans here, man. We call shit all kinds of stuff. As long as at the end, I don't want to see any Q in your freaking answer that you box. Because there ain't no Q in the beginning question. Okay, good. Kick ass. You really have to start to understand how much flexibility there is in how you do your problems. Very often, there's some weird shit we do in the middle as long as you come back at the end. And that's basically what U sub is, for example. Right? Okay, maybe? Not really. Screw you, Jeff. Is everybody kind of cool, at least with the next few steps of the problem? Mm-hmm. Okay. Then we get further on the problem and hit a snag.
What?
Did anybody get further on that problem and hit a snag? Not yet. Did somebody get further than this on the problem and found a blockage? Okay.
Oh.
Not sure how else to say that. Okay. No. All right. So come back to me when you do, if you do. Anything else, homework-wise? Okay. Let me remind myself. I think we didn't finish that worksheet. Is that true? Remember this worksheet from last time?
Yeah.
Oh, no, we didn't finish. I think we just needed one more.
There were these 3 on the back here. Yes? Come back to me.
Yeah.
Come back to me. Come back to me. So in the interest of time, oh, by the way, the first test for us is on, is it the 5th?
It's a fifth, yeah.
Okay, and when is the 5th? Is it
Thursday.
next Thursday?
Yeah.
Okay, I gotta keep myself on track. So here's how this works, because that'll be our first test. This Thursday, I'm gonna give out a practice test. Next Tuesday, we will not do any new stuff. Maybe a couple of, depending on how far I make it Thursday, but most of next Tuesday will be devoted to review for the test. I'll have the answer key to the practice test. You can ask questions from any day. You guys good? And then Thursday's the test. You'll have the entire time for the test. I won't make it to take the whole time, but you'll have the whole time. So bear with me.
Yes.
And you can make corrections to test. Just keep that in your head. Same way quizzes work. Yeah.
All of them up to 7.8, right?
I'm almost certain we'll make it through 7-8. I will know better come Thursday. If we don't make it, I'll tell you exactly what sections. But right now, my plan is to make it through 7-8. Yeah. Yes. Anybody else need one of these? One of these. How many do I have? 3. Anybody else? Uh-oh. I have 3, but one of them is mine. How do I not have enough? Damn you, Jeff. I should have had plenty. Wait a minute. Oh well. Well, if you guys are nice to me, I give one of you guys one of these. That's got all the work on one side. Who else needs it? Just 2 more people? Okay, that's all I see is 2 names. Good. All right, so. The first problem on the back there, I think, was this. Is that right?
Yes.
Okay. Is it that? No.
Oh, X over.
Oh, X.
Oh, yeah.
And
Silver.
X and 1 are, yeah.
Over 1 plus rata x? Okay, that's much better. Oh my god. Okay. All right. I love, once you see how this problem works, it really opens the door to other possibilities. And I think there's a couple problems that involve what we're about to do. So when you're really stuck, and you're like, I don't have a freaking clue. I mean, if you look at this thing, there's nothing that really jumps out at you. Is it a trig sub?
No.
Right? No. Would you want it to be a trig sub? I mean, you could actually finagle more things to be trig sub. I don't want to do that with this shit. No, thank you. Is it like a direct U sub?
Direct.
Direct U sub. Is it a direct U sub? Is somebody's derivative in there that's in there also? No. It will be a creative U sub, though. Yes. So who managed to try this out and get something to work? Or does somebody have a good idea? Yes. Yes, and that kind of goes with a general theme. If I could choose how many terms to have on the bottom, I'm gonna frickin' choose 1. Because then I could break all the shit on the top up, yes? So when you're really, really struggling and you have a fractional thing in your integral, let U equal the entire bottom. Is it always gonna work? No. Will it sometimes work? Shit, yes. I need you to be with me on this. If the bottom is 1 term, life is much better. It just is. The bottom being more than 1 term sucks. Now, unfortunately, I do see some people, please, dear God, don't write this. I do see some people doing this shit. Okay. And I'm really sorry to be very blunt, but that is complete pure shit. I need you to understand where I'm coming from. There's a lot of, I'm not sure how to say this right. There's a lot of people that are algebraically manipulating things incorrectly. I don't know if it's in the moment you're being optimistic or forgetful or whatever, or if you have a misunderstanding. So the most common thing I see is something like this. Does everybody understand that that's not true? If it was true, so much of what we've done would be so much easier. But then it becomes really easy to get the wrong answer, which is bad. Are you guys at all with me? So I don't want it to come off as if, there's no way to say this correctly. You're in Calc 2, you have to know your algebra. You have to. If you don't, how can you build? You can't build. So if you notice you get a test back, a quiz back, and for example, and I'm really sorry for this, but if you do this kind of thing, I'll put next to it what? I'll do that. I will. I will, because I'm an asshole. But what I'm trying to show you is this should not be happening. It's a signal to you to go, What am I incorrectly assuming? If I think that's true, let me go get some help. Let me ask somebody why this is not true. Are you with me? That's how you interpret that. I'm not making a judgment about you as a person. I'm saying that kind of mistake should not happen. And if it is happening, you got time to kind of work on it. We haven't taken a test yet. Okay. So get that out. So if I let u equal this, now here's the neat thing. If this is going to work, and on the top I have x, I have to know what x is so I can replace it. So I might as well, if that ever happens, are you guys seeing that? We've seen some use of like this, where I solve for x. If you ever think I have to solve for x, do it immediately before you take a derivative. And I'll show you why. How do you solve this for x? Yeah, subtract 1 and then square. Is that cool? Because now, instead of du equals bullshit and I have to make it show up, I just know exactly what to replace dx with. What's dx equal? You can do it.
3 times u minus 1.
Yes, 2u minus 1 du, right? Inside's linear, the chain rule doesn't show up, blah, 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 blah. So now do I have everything I need to rewrite the integral in terms of u instead of x? Yes. If you ever rewrite using u sub and there's still an x thing left, you have done something wrong, go back. Some of you guys keep going somehow, right? So what I'll see is stuff like, somebody will make a u sub. If you see this, erase, back to the last good place. This is the bad place, yes? You'll see the timeline, everything's gonna get really weird. If you never saw the show, it's okay. But I see people doing stuff like this, and that's extra neat, because if this was a product and I was taking a derivative, there's a product rule. So it has to be even worse for integration. And this is an implicit function of u, and I don't want to integrate implicitly if I don't have to. Okay, let me stop for a minute. Is everybody kind of with me? So if you're doing u sub, and you have an x dependence left, you have made a mistake. You either chose the wrong thing for u or whatever. Get out of here. So if I rewrite this, what do I get? What's x?
U minus 1 squared.
Yeah, u minus 1 squared. What's the bottom now? U, and what's dx?
2 times u minus 1 du.
And now that's I'm not even going to do anymore. That's easy. Foil the top out a few times. Break it up over u.
The Pascal's triangle.
Yes, Pascal's triangle is really good. Do you guys know Pascal's triangle?
No.
I'll show it very quickly. Is everybody semi-cool? That interval is easy. If you don't know Pascal's triangle, just foil and then foil again, yes? And then split it up over u, and then easy interval. Power rule, power rule, power rule. Okay. Pascal's triangle is kind of silly. I love it. It's like somebody was just bored and said, oh, look at that. Oh yeah, 1 plus 1 is 2, and I just keep putting 1s on the outside. 1 plus 2 is 3. I put 1 on the outside, 3, 3, 1. Look at that. Right? But then if you do x plus 1 cubed and you do all the work, you end up with x cubed plus 3x squared plus 3x plus 1, 1, 3, 3, 1, 1, 3, 3, 1. Freaky! Right? And it's just because of the way that shit goes together when you FOIL stuff out. This is all about putting stuff together. When you FOIL, it's all about putting like terms together. That's why they have a connection. Did it just prove it? No, I don't care. Just a little side note. Do you ever have to use Pascal's triangle? No. But I want to show you like the next level of this, just in case. So this would be, you guys, what's x plus 1 squared if you did it? Yeah. Is everybody with me on that? Does everybody agree? What are the coefficients? 1, 2, 1. So this is the squared piece. This is the cubed piece. And if you wanted a fourth power, you can keep going 1, 4, 6, 4, 1. Yes? So if I had 2x minus y to the fourth, would you be excited about writing that 4 times in FOIL? Would you want to come up and kick me in the shin, or the knee, or the nin, if you want to do both? Put a big shoe on. So watch this. Here's how this works. You ready? Do you see how I start with the most x's, and do you see how I really need this to make sense? Do you see how the number of x's went down by 1 each time? So here's what's really cool. The ones do the same thing. All x's, no ones. 2 x's, 1 1. 1 x, 2 ones. And then all 3 ones. So they kind of do this. So what am I going to do that? I'm going to have 2 x's. Then I'm going to have minus 1. What's my coefficient? 4. 1 less 2x. 1 more y. Now, if you want to, you can actually just put plus and put a negative y in there. Then I'm going to have plus 6, 1 less 2x, 1 more negative y. Plus 4, 1 less 2x, 1 more negative y. And then plus all 4 negative y's. Do you understand? So much. And then you clean that up a little bit. So much quicker than doing a 4th power, writing it 4 times. Has anybody ever, pretty sure you've never seen that before, anybody?
Like,
A few of you guys? Doesn't make any sense. I went very quickly, and I'm sorry, I'm not going to say another word about it in class, unless somebody asks about it. But this is on you to look it up if you want to see more. This happens often enough that it's good to know. And unfortunately, a lot of you guys kind of know this, but people don't show you an example with more shit inside. It's the same thing. All of the first one. 1 less of the first one, 1 more of the last one. 1 less, blah, 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 and then the coefficients, bam. Okay. I'll stop. Okay. Anything else? Did I finish answering that question? I hope so. Anything else from the quiz or from homework? Okay, so let's get back into this. Oh, wait. Was it in the middle of this problem? Which problem was it? Where did I put it?
You couldn't finish it.
What's up?
Because it was simple?
Yeah, is everybody cool with that? You guys cool with that? Is it easy from here? Is that all right? Because here you have u minus 1 cubed over u with a 2. So you can use Pascal's triangle to do this, and then break it up, and then you just have polynomial in u. Yeah. What's the next part?
I think we're done it up.
Second problem on that. I gave all my stuff away. I'm sorry.
sine cube 3. Wait.
Sine cubed over sine.
Sine cubed of x.
Yeah, of x, sorry. I was trying to say x, but I was having a brain fart.
And then over sine times cosine squared plus sine cubed of x. On the bottom. And then dx.
Yeah, okay. So this is me just reminding you, before you try to do anything, before you try to do U sub, before you try to do whatever, where are my 180 students? What do?
Simplify.
Simplify, right? Simplify me. Because if you can simplify the shit you're supposed to attack with calculus, you have less shit to attack with calculus. That's almost always good. Who can immediately see what happens here?
We get rid of a sine.
Yes, everybody's got a sign, everybody a sign. So I can kill a sign there, I can kill a sign there, I can kill a sign there, and all of a sudden,
We have a 1.
pretending like you can read my writing, you get sine squared over 1, yes?
Yes.
The most basic Pythagorean identity. This is a thingamajig. So then you get this, and then I almost don't care. Because now it's just, do you remember the identity for this? Is everybody with me? Dear God, even before you rule out U sub, just step even a little further back and go, is there anything I can simplify? Can I factor? Can I cancel? Can I do anything to simplify this dumb thing? Okay, maybe. Screw you, Jeff. Okay. And then what's the identity here?
1 half. And then 1 minus cosine 2x dx.
And then that's just too easy, right? It's 1/2 x. What's the integral of cosine? 2x?
1 half sine 2x.
Yeah. Let's see, and then you distribute the 1/2 x, blah, 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 blah. Yes? Why is that 2 there?
Because of the 2x.
Because you have to kill the 2 that would come out?
Yeah.
Does everybody get that? No? What's up? You guys all right? All right, look. What is the integral of e to the 4x?
The integral 1.
I know this has to be part of the answer. I know it does. Why is that not the answer? Why is that not the answer?
Because of the chain rule.
Its derivative is what?
That
Times
the derivative
4, yes? So that it can't be the answer, because the answer's derivative should be this, yes? So where did this come from? This is what I don't think students understand. I have made a guess. I've made a really good guess. I know this has got to be part of the answer. I know it does. I can still adjust this, because this is just a guess. Students don't seem to understand. The minute I write this down, I'm not saying that's the answer. I've taken a guess. I take this guy's derivative. There's a 4 that isn't there. How do I kill that 4? Divide by 4. Okay, good. So, I mean, we see this dumb thing happen so many times. When the inside of a function is linear, there's just a constant that I have to kill. I don't have to use u sub. I just have to kill the dumb constant that would come out. Dumb constant. Okay, maybe. Maybe? Potential, a little bit. You maybe understand it less, Jeff. Okay. Can you do the same thing on this? Hell no! In fact, does anyone know anything about this integral? Do you think it's doable?
By parts.
Nope. This is called a non-elementary integral. You cannot do this directly by hand.
Power series?
Chapter 11, power series, we're going to be able to estimate the answer to any arbitrary degree. The answer will end up being an infinite sequence of terms,
Oh, great.
which we'll call a series because we'll be adding them together. But that's chapter 11. Okay. I love you guys. Cheers. Okay. How's everybody doing? You guys semi-okay? Okay. Okay. And what was the last problem? As I run out of paper.
1 over x times radical ln of x plus 3.
Yeah, this one actually is the last problem, but it's probably the easiest problem.
Yes.
Because you can see directly. Would I let u equal ln x? Isn't this derivative in there? Why is u equal ln x kind of not the best option here?
Because then you just leave the 3.
I would have a plus 3 sort of left inside that actually, to be honest, wouldn't be that hard to deal with, but I don't have to. In general, if I see a function whose derivative is in there and there's a constant, make the whole damn thing u. Because this derivative is still just going to be this. So then I get u to the 1/2 on the bottom, so u to the negative 1/2 du, which is 2u to the 1/2, which is 2 times this business. I think so. I did that a little quickly. Yay! Thank you. It's good to be validated. All right. So, I think some of us came in with a less than good understanding of u sub. And what sucks about that is, by parts, the more you understand u sub, the better you can delineate by parts. The less you understand u sub, the more they kind of overlap, and then you start doing the wrong thing at the wrong time. Real quick, here, let me give you an example. What do you got, Jeff? I don't know. It doesn't matter, dude. There you go. What if I try to let u equal square root of x cubed plus 2? I'm not saying this is the right thing. And then I'll let dv equals x squared. What have I done wrong?
X squared is not there. It's 1 over x.
There is no x squared in there. There isn't. There's no x squared in there. Yes? Does everybody really understand that? The whole idea of by parts is I have something in the form u times dv, and then I identify what this is, and I identify what that is. So if I call u this piece, then 1 over x squared would have to be dv. I'm not saying that's the right way to do the integral, I just made it up. There's a very specific problem I'm thinking about in homework that a few people had the wrong, that did this basically. Okay. Maybe. Okay. So that's that sheet. So has everybody gotten into partial fractions? You should be definitely into partial fractions. Is that going okay so far? I'm guessing so because nobody's got questions. Okay. 7.5 was basically that sheet we did just now. We finished it up. It's got all the forms of factoring in there. I didn't put it by parts on there. I don't remember why I didn't. I think I just forgot. Let me think. Yeah, okay. If there's no questions, I'm going to get into 7.7. Because we're just that crazy. 7.7 is neat. What's really neat is, oh man, it's my last sheet of paper. Oh, here we go.
Yay. Yay.
Look at that. Oh, I got more of those. Okay, there's 2 more sheets. That's awesome. Do you guys remember, who knows what Riemann sums references?
When the area and you add it by like multiplying and taking just the area. and
What
then
shapes do we
add
use for Riemann sums?
trapezoid.
No. We didn't use
Oh, that's
trapezoids.
the other one.
We're about to use
Rectangle?
trapezoids. We use rectangles.
Oh.
So we had a, I could have a function that's doing all kinds of trippy shit, blah, blah, blah. And if I want to know the area, I could break this up into these Fisher-Price kind of blocks, yes? Blah, 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 yes? These chunky blocks. And I could increase the resolution by increasing the number of rectangles, blah, 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 blah. Why was that stupid nice? Because if I increase the rectangles enough, rectangle areas are easy. I get a good approximation really easily. And this is before we knew how to integrate. This led to integration. This led to us connecting the area under a graph with the antiderivative. Okay, maybe. And that was huge. That was huge in 180. Hopefully your teacher made a big deal out of it, because that is huge. Okay. Rectangles are dumb though. Let me draw a little better picture here. Something with a little less happening. Okay. So if I want to know from A to B, a rectangle is kind of dumb. If I go here, I could overshoot it, right? Okay. So an immediately much better shape to use is a trapezoid. The side isn't curved, but the side follows the function better than. The whole problem with a rectangle is it's either too high on this side or it's too low or something, right? If I use a trapezoid, it's able to kind of like follow the surface better. My error should be less. But now the question becomes, okay, rectangles are beautiful. I could just take the area and add them together. And the area is just the width times the height. Yes? Now I've got trapezoids. Who remembers the area of a trapezoid? Well, first off, what is this still going to be? Delta x. That'll be the width. That tells me how wide they are along the x-axis, yes? What's the area of a trapezoid, though? Let me draw like a standard isosceles trapezoid. Let me put some stuff in here. So a trapezoid looks like a beheaded triangle, yes? Okay, and I apologize. My math is very bloody and violent. Things kill each other. Somebody beheads a triangle. But to me, I think some of you guys should know the area formula for a trapezoid, but this is kind of a neat way to realize the area formula for a trapezoid should be very similar to the area formula for a triangle, because this is almost a triangle. Somebody cut the poor dude's head off, right? Okay. Does anyone remember the formula for the area of a trapezoid?
I know there's a half.
There is a half in there. So the area for a triangle is 1/2 height times base, yes?
Yeah.
But now how many bases are in a trapezoid?
2. So just adding them?
Yeah.
Okay.
Now I could prove it, I'm not going to. So you draw like a diagonal, you have 2 triangles, you find both areas, you add them together, and you get this. Let me draw a diagonal. You get 2 triangles, find their areas, add them together, you get that formula.
I was just
Yes?
making complicated. I was thinking of like that plus B like separated. Like if you
Oh.
were to like
Oh, I
like,
see. No, don't do that.
distribute, that's how I thought of it. Like
I'm with you.
1/2 times height times
B1 plus 1/2 times height, and which is the two triangles you make.
Yeah, that's
Yeah.
what I was thinking really.
But then it leads to this when we factor.
Nice.
Yeah. Is everybody with me so far? I need you with me. So what's interesting is when I had rectangles, what was the height determined by?
One?
Yeah, the function value at that point, yes?
Yeah.
Okay. This trapezoid, how does it relate to that trapezoid? They're very different in, at least now I know one side is flat, but I don't care about that. How are they most fundamentally different?
The base is the height?
That's been termed, yes?
Yeah.
These are the bases. What's the height then?
The width.
No, the height is delta x. See that? The height is delta x, that's the constant height, and then these are the two bases, the two function values. So if I call this x0, x1, and what else do I want to say here? No, that's cool, okay. What would the area of this trapezoid be then? What's the height?
X minus.
What's the height?
Oh, just leave delta x.
Delta x.
Okay.
What's this base here? F of x0. And what's the other base? F of x1. F of x0, F of x1. That's the height, I'm sorry, the length of the base and the length of the base. Is everybody with me so far? So this looks, without the 1/2, it looks very similar to rectangles, yes? Okay. What would the next trapezoid be? Area. This is area of the first trapezoid. What would the second trapezoid's area be? I'll get it started.
Saying you just change the 0 and the 1 to 2 minus 1 plus 1.
So what's this base now?
Base 2.
Yes, but what is it exactly? That's the base of this trapezoid, correct?
F of,
F of x1
yeah,
plus
F of 2.
f of x2, and this is still the same width.
Yes.
So that's the height for us here. So what do I have so far? What's the cumulative area so far? The total area so far would be 1/2 delta x, f of x naught, plus 2 of these, plus 1 of those. So if I just continue, and I call this, what am I going to call this? This will be xn. Do you see how everything in the middle gets doubled? Because everything in the middle gets used twice, but the first dude and the last dude get used once. So the area total, what? Screw you. What area total so far? So the area total would be 1/2 delta x, f of x naught, plus 2 f of x1, plus 2 f of x2, plus dot 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 f of xn. So you just double everything in the middle. Are you guys at all with me? What's happening there? Okay. So I don't know how well you remember Riemann sums. I have no idea how you felt about Riemann sums. How you should have felt about it is sweet. Because all I gotta do is plug shit in. Yes? How do I figure out the width? Can somebody remind me how to figure out the width? How do I figure out the width? How many, what am I doing? How do I figure out the width? How many trapezoids am I using here?
N?
N. So I don't know if that's right, but I'll be okay. So this will be B minus A over N, like it always was.
Okay.
That's how many trapezoids I'm going to use. Okay. Whatever you say, Jeff. There's no left and right endpoint here because we actually end up using everything. In fact, we used most of them twice, right? You guys with me? Yes.
Can you repeat where the 2's came from?
Oh, do you see how there's an f of x1 here and an f of x1 there? So if I add what I have so far for the first two, I have one of these, 2 f of x1s, and one of these.
So the x of 0 is always just 1.
There's only one of them because it's only involved in one trapezoid. x2 would be involved in the next trapezoid. So the only ones that I would have one of is the first dude and the last dude, because they're the only ones that are involved in only one trapezoid. Okay, I like it. Let that be nice. Let that be relatively nice. I mean, you know how to get the delta x, which tells you how to get your x0, your x1, because x1 is just x0 plus delta x. You plug all those things into the function, you plug it all in here. It's just a bunch of plugging shit in. Relative to other stuff we've done, let that be easy.
Is this not a name? Like the other ones?
Yeah, you ready for it? You're never going to guess this.
Something trapezoidal.
You're never going to guess it. That's a good guess. It's the trapezoidal rule, yes. It's not like the Hamburgian proposal. No, it's the trapezoidal rule. Okay. Now the next one's neat because it makes you think: is there going to be donuts involved? But Simpson's rule. This is really cool. What is still the problem with even trapezoid? They do a better job, but why could they never really follow the curve well? Straight lines. So why don't we use curved lines? Why don't we approximate? And some of you guys are like, because I don't wanna. Well, it's too damn bad. It's too damn bad. So what Simpson's rule says is, why don't we use parabolas? So this is really neat. So here's the idea. I'm not even going to try to draw this picture. I'm just going to show you the book, and then I will draw some pictures, but not this main one. What is it? 7. Here we go. So the blue is my estimation, and the red, I believe, should be the function. Yes. So what's going on here? Let me zoom in on this. Sure, stay there. Stay there. Come here. This is exciting. Freeze. Okay. So I got my function. Yes, red. Red is my function. Blue is my approximating, in this case, quadratic, right? My parabola.
Okay.
So I have these regions. Notice how many inputs define a region.
6, 7.
3. That's going to lead to a requirement in terms of how many things I could break my interval up into. With trapezoids, with rectangles, I can break them up into anything I want. With Simpson's rule, I have to break them into an even number of subintervals.
Okay.
Otherwise, it won't have enough for the last poor little polynomial to exist. Let me stop for a minute. You see up here there's 6, yes? So basically these two go together, right? And then the last one is sort of like involved in the next one, the next one, the next one. So you need it to be divisible by 2. So you can't use Simpson's rule if you want to have 7 subintervals. You'd have to make it 6 or 8 to make it work. Okay, you stop for a minute. What degree are parabolas? Second. Why with trapezoids and rectangles do I just need 2, not 3? Because they're linear. To get a linear function, I need 2 pieces of information. How do you get the equation of a line? You can get it if I give you 2 points, correct? How do you get the equation of a parabola? I have to give you 3 points. So it's a second degree. So therefore, I really want you guys with me. The equation of a line is mx plus b. M and b are my unknowns. So that's why I need 2 pieces of information to construct a line equation. Parabolas, ax squared plus bx plus c. I have 3 unknowns. I need 3 pieces of information. I need 3 points to put together the equation of a parabola. Let me stop for a moment. Is everybody with me so far? I really want this to make nothing but sense. If I wanted the equation of a cubic, I would need how many points? 4. It's always 1 more, because I always have that constant at the end that makes it 1 more unknown I have. Okay. Now, a really good question is, dear God, Jeff, I know the equation of a rectangle. Hell, I even know the equation of a trapezoid now. But now you got, what the shit, Jeff, is the equation of this? I don't know either, so we don't. So here's what we're going to do. First thing I'm going to do, just to make things easier to derive, I'm going to take this guy and I'm going to shift him. If I just took this guy and I shifted him, did I change the area? Is everybody with me? The area is the same. In fact, what's the whole point of this whole damn thing? Find the area. So if I do something that maintains the area, nobody can complain. In fact, you're all going to love that we're doing this. Okay. Or at least hate it less. Let me say it like that. Good Lord, Jeff. Get in there. Okay, here we go. So I'm going to translate this over. I'm going to move this back. And I'm going to show you, I'm going to move this first one back. Because whatever I do to the first dude is basically everything I do to the other ones. So I just want to establish the procedure. Same way we did the trapezoids. We figured out what to do with the first one, and then we just repeated it. Okay. So what I'm going to do is I'm going to shift that first dude so that the width I'm going to call the width h, just because.
Okay.
So now if I shift it back so it starts at negative h, let me see, do I want, yeah, sure. I'm going to try to draw just the blue parabola piece, yes?
Okay.
So I just shifted it back so it starts here and it ends there. So then here's my points that I want to use. Okay, this is going to be trippy. What we're about to do, I always want to warn students when we're about to derive the rule. You never have to do the derivation, you just have to apply the rule.
Mm-hmm.
But especially with me, I'm never going to let you use something that you never saw why it exists. Right. Can somebody tell me, you're going to love this. Somebody please tell me the equation of this parabola. Now, what's a really good thing to say right now? What do you want to tell me? I want to know the equation of the parabola. What should you say?
I don't know.
We don't know what the shit it is, Jeff. All right, so what is it? What's the equation of this line? Y equals mx plus b. What's the equation of that parabola? Y equals ax squared.
Plus bx plus c.
I don't know why I made one thing. Do I want them capital? I don't know. Yes, I want them capital. Make them capital. Just so I bring back twinges of partial fractions, so it's even worse. Okay. Anytime. You can count on me to make things worse. All right. So that seems really lame, but that's what it is, correct?
Yes.
Now, find the area under that curve. Go. Find this area. So let me ask you real quick. Do you know what the function is on top? Yes, you do. What is it? What's the top? What's this function? That one. Yes?
Yes.
All right. Where are you going from to? All right. Can you set up the integral?
Mm-hmm.
Okay, do it. Don't worry. I'm not going to let you go through this whole thing on your own, but try to set up the integral. Don't overthink it, and don't say it yet. What are you saying?
I can't.
Blah, 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 blah,
if
blah.
I just say something.
Oh. I just sit next to you if you got to take a test. What's she saying? Oh, yeah. Oh, yeah. All right, that's a good place to start, right? And then you just throw all the shit in there, yes? Now listen. I don't blame you. Right now you're sitting there going, what is this doing for me, Jeff? But isn't the whole point of this is whatever that parabola is, I need to get its area. So I'm going to do this in two stages. We're going to get the area in a very stupid form. And then we're going to do something else to hopefully make that form better. Just go with me. Everything I've done so far is technically right. What do I do when I draw a rectangle? When I try to use Riemann sums, isn't the first thing I do is find the area? So what we're doing right now, what's the first thing? We drew a parabola. What's the first thing we do? Find the area. That's what we're doing. Do we have a geometric formula for the area under some arbitrary portion of a parabola? No. What finds areas? Calculus. Sweet. So what is this integral?
Oh, 1/3
1/3
ax cubed
plus
1/2
1/2
bh.
bx squared
Yeah.
plus
Cx.
cx. And I'm going to go from negative h to h.
Yeah.
One thing to notice, do you guys understand? Let me see. There's a little bit of a shortcut. I'm going to do this the whole way out, but just if you ever see an even symmetry piece, it's going to cancel itself between these two. Because bh squared minus b negative h squared is bh squared, so that cancels. But let's do it all the way up. So I get 1/3 ah cubed plus 1/2 bh squared plus ch minus 1/3 a negative h cubed plus 1/2 b negative h squared plus c times negative h, blah, blah, blah. Yes?
Yeah.
So I end up with 2/3 of these, because that, of course, becomes minus and negative plus. These cancel, right? This minus itself.
Yeah.
And then these combine and make 2ch. Stay with me now. Where did I put that? Damn it. That's too bad, Jeff. I'd worked this out ahead of time, but I don't know where I put it. It's too bad for me. Now, if I relate what I have in that picture, here we go. Let me say this. This was x0. This is x1. This is x2. This is y0. This is y1. This is y2. Yes? Which, of course, is f of x0, blah, blah, blah. Y'all with me?
Yep.
So I looked at this one way. I'm going to look at this the other way, more directly. Because now, for example, I know that... Let me write this area a slightly different way first. If I do something really kind of weird... In fact, no, I won't. Here, I'm not going to do it that way. Okay. Sorry, guys. I'm doing something live. I've changed my mind about something I wrote. I'm going to do this later. It'll make more sense, I think. Is this making any sense? I mean, technically, if I said find the area, part of your brain would hate it because I didn't give you any numbers. But then hopefully part of your brain just goes, freaking brute force the damn thing. I know how to find the area of anything, any function from anything to anything. I know how to set it up at least. This is a freaking polynomial. Okay. Now, remind me, we know what the equation of this is. Do we have points that this is supposed to go through?
Yeah.
What points is this supposed to go through? Give me 1 point.
0,
x0, y0,
Yeah.
x1, y1, x2, y2. Is that cool?
Yeah.
Okay. In fact, let's be even better. This is the point negative h, y0. This is the point, what is x1? 0. And this is the point h, y2. Is everybody with me?
Yes.
So what does this really mean? This means when I input in negative h, what should my output be? When I input in negative h, what should my output be? y0. When I input a 0, what should my output be? Is everybody with me? Whenever I know points, I know the inputs, the outputs. When I input an h, my output should be, that's crazy. That's crazy. That's crazy. So what is y0? It's just ah squared plus, I'm sorry, minus bh plus c. y1 is just c. y2 is ah squared plus bh plus c. Now, do something very strange for me. Is everybody cool? Does everybody see that? I want you to take y0 plus 4y1 plus y2. Just take a moment, take y0, add 4y1, and add y2. Why? I don't know. I just want to keep you guys busy and out of trouble. What we're doing is in less than 30 minutes, we're recreating what took people a little bit of time to kind of like derive for themselves. We're always doing that. Every damn time we do anything, we're compressing potentially years of work into 20 minutes, right? So there's no reason you should say, yeah, of course I would have done this.
No.
No, this is people that didn't have anything. What did they have? Did they have YouTubes? Did they have the Xboxes? Did they have anything? No. They had candles and paper and pens. And some of them could write and read. So, they just played with this kind of shit. Okay. I'm sorry. Oh, jeez. What do you get?
I got 2AH squared plus 6C.
Yes. Okay, now, let's take what we figured out. Hold on. Has everybody got all that? Okay. So I'm going to remind us. Y0 plus 4y1 plus y2 was 2AH squared plus 6C. And earlier we got that the area under the curve was 2/3 AH cubed plus 2CH. Sorry? Yeah. Can you make this look like this? Yeah, I think you just said it. What do I want to do with the number of H's? Can you make this look like that? Can you take stuff out? Take out a what? An H? Yes. And? I want a 2 here, not a 2/3. I want a 6 here, not a 2. What can I take out? 1/3. If I do that, don't I get 2AH squared plus 6C?
Yeah.
I love you guys. Again, who would think to do this besides a bunch of people that only time for this? Nothing else to fill their time. So what the shit, Jeff? Well, now I know the area. In fact, isn't the area the whole thing? What was the most important thing we were doing Riemann sums? Find the areas of the damn rectangles, and then we can add them all up, correct? The area is the whole point. That's the formula for the area, but I want it related to my inputs and my outputs, right? So now this will be 1/3 H, and what is this? That. And what is this? F of x naught plus 4 times f of x1 plus f of x2. Yes? Y0 is f of x0, blah, 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 blah. Yes? Isn't that looking a lot more like, now listen, it's more complicated, which is not a surprise. But can you see how that looks very similar to trapezoid? Which looks very similar to rectangles, just more complicated. Each level got a little more complicated, which makes sense. I'm fitting the curve better, which requires a higher level of complication. What would the second, so let's say this is the first. This is an area of this, and that area didn't change just because I shifted it back. It's the same dumb area. I just shifted it back to make the work easier to look at. So what's the area of the second piece? What do you think?
Let me see the
Yes. x0, x1, x2. So now it's x2, x3, x4, right? So what's the area of the second piece? Good. 4 plus. Sorry.
Yeah.
I'm really bad about it. I miss my chalkboards. I'll be all right. Come back. Stay. Okay. And then you keep going. So in general, we understand that the number of subintervals has to be even Yes? So what you end up with, here, I'll be smart for once. You ready? What's trippy is the 1/3, if you really think about it. That's not immediately obvious why it's there, and of course it isn't because we got here through integration and all kind of stuff. So,
Yeah.
so here's what it ends up looking like. N has to be even. And look, delta x, same dumb thing. Thank the gods. Yes?
Yes.
Now please, I need you. You just got to get in here and try this. I need you. If I wanted to go, here. Let's do an example. Oh, I do. Somewhere. Look at me. I've got a freaking worksheet. All right. I got all this shit written down. What the hell am I doing?
Thank you. I like this one. Oh, I like the simple stuff. It's like part. It's complicated. It's not like it's easy. It's not like it's hard. It's like a lot.
Oh yeah, sure.
This is just something that I can like. It's like. Yeah.
Yeah, okay. So very quickly, well not very quickly, but semi-quickly, if I tried to break an interval up, good lord, into like 5 parts, so like, you could do it, Jeff. 1, 2, 3, 4. Okay, so they're not even, but oh well, too bad. Let's see what would happen. Just to cut to the chase, I would have f of x0, just looking at the part of the equation that relates to, I really want you guys with me, instead of writing the whole damn thing, I would have f of x0 plus 4f of x1 plus f of x2. Yes, are you everybody with me so far?
Mm-hmm.
And that would be the parabola that's fitting this piece.
Yes.
So there's a parabola that kind of fits this piece, blah, blah, blah. Okay. And then I would start over again at f of x2, yes?
Yes.
Plus 4f of, so many parentheses, Jeff, x3 plus f of x4. So that would be these 3. But do you see the issue now?
Yeah.
Because now where do I start the next thing? F of x4, yes? Do I have enough?
No.
That's why it's got to be an even number. That's why I can't stop. I have to have an even number of little intervals I break this up into. And another reason to look at that is why how many little subintervals does every parabola kind of like have in itself? How many subintervals are involved in this one parabola? 2! If every parabola needs 2 subintervals, I have to have overall an even number of subintervals. Good. Okay. Very good question. Because I didn't even think to say it the way I just did, which I think makes more sense. Okay. So let's see, what do I have on this sheet? Oh yeah. This is a beautiful example of something that we can only get approximations for.
Okay.
Come back to me. Go away. Come back.
Go ahead.
Please. Thank you. 2 to the x squared is a non-elementary integral. You cannot find a closed form for the answer. And you'll see what I mean when we get to chapter 11. Trapezoidal rule. In fact, let's do this. What will the width be no matter which rule I use? And by really quick, I'm sorry. I am not overly concerned about the error. I'm not going to prove these errors.
Okay.
But I do want you to notice one thing. Do you see how which one of these errors is bigger?
The first one. That one.
Yeah. The first one's bigger. Yes? Simpson's rule, it kind of makes sense. Since Simpson's rule allows itself to curve, it should have a smaller gap between itself and the actual function. Okay. So its error is always going to be smaller than any of the other rules we've used so far. Okay. So I don't know. Do we want to do both ways here? What's the width going to be no matter which way I do this? Yeah, because I've got 2 minus 0 divided by 6, 1/3.
Yeah.
So let's do this by itself. I'm going from 0 to 2. Can we figure out what my locations of my subintervals are? Not too bad, right? Let's see, 6 subintervals. So I can do. I'll see if I can get this to work out. Where's this go to? That's crazy. And then
2/3.
that's crazy. And then
1.
and then
4.
4/3. And then 5/3. And then 6/3. Yes. Okay.
Two.
So that's going to be for both trapezoidal and Simpsons, right? So what's kind of nice about these is it kind of overlaps the information they use. Each one uses kind of like the same information. They just have it a different form for the answer. Do you start to understand now that, do you see how to do trapezoidal rule, you have to know all the outputs at those inputs we just figured out? And then once you got those outputs, you need them also for freaking Simpson's rule, yes? That's nice. So it's actually kind of nice to have a problem that makes you do both methods because there's a lot of reuse of information. So if you just figure out what f of 0, f of 1/3, do you guys know how to use your calculator to get that information very quickly?
Yeah,
The table?
the how you put the table and then the equation you want and
Yeah.
then the values you're gonna put in.
Oh
the
shit. Of course I didn't bring my calculator. Too bad for me.
You know,
Yes. I like this one. This always makes me think it's like a Department of Transportation.
It's fancy.
Yeah, it's neat.
the Department of Transportation.
I don't know, it's yellow and stuff, you know what I mean? Like, so that they're working on the road and it's night and people can see them.
I learned how to
Oh my
use
god, my calculator saved my life. I'm gonna make this a little brighter, is that okay?
Yeah, that's
Okay. So y equals, ooh, somebody was trying to think maybe. What was that again? Where'd it go? 2 to the x squared, okay. So 2 to the x squared. Oh my gosh. Now if I go table set, is everybody with me? Second window table set, started at 0, go by 1/3. Now I know some of you guys know about the ask and all that shit, but since my delta x is the same, I'm just gonna let it know what delta x is. And then if I go to table, I've got all my inputs and my outputs that I need. Yes?
Yeah.
So, yay. I'm not gonna make you do that shit by hand. Yes?
Can you go back to the table set?
Yeah, sorry. So table set. I know I want to start at 0. And I know my step size is 1/3. So I just typed in 1/3 and the calculator said, oh, you mean about that. Okay. And then when I go to table, my inputs, my outputs. There's f of x0, f of x1. Is everybody with me? Do you understand why I don't want to do this? Because you just shove this shit. Please be with me. You just shove this shit in there and do it. And then you shove the same damn numbers in there, and you do it. Yes? The interesting part is deriving these formulas. Using the formulas is just busy work almost. You just plug it in and get a number. Then you can compare it to the actual integral, which, well, not the actual one. What's really neat is when you do this, what is a calculator? Holy shit.
Oh, sorry, I zoomed it out really wide.
Okay.
Sorry.
No, you're fine. Sorry. I have to laugh at my own reaction. what the shit? All right. If you do, did I do it? Second Calc 7. If you go from, what was it, 0 to 2, then that. And then your real good question should be, well, what's the calculator doing? What is it doing to get that number? Did anybody learn Newton's method in Calc 1? Did it even have time? I looked at it really quickly. It really makes me sad because Newton's method, the TI calculator, to find the intercepts for a function, it uses a modified Newton's method. Does Newton's method sound familiar to anybody? All right. Some of you guys like, I'm not going to commit, just in case you ask me about it. I don't blame you. But there's a class called numerical analysis in which you learn the math behind the algorithms that calculators use to do things like this. Somebody with me. And to be very honest with you, I'm not sure what TI does. I tried to reach out to them with some questions and they thought I was a spy from HP. I'm not joking. Got the email response back somewhere. They're like, we don't know what your motives are in doing this. And I'm like, I'm the teacher, just want to show my students something neat. Screw you guys. All right, gotcha. So I'm on some kind of a blacklist in TI, which is neat. Thank you for this. Is that okay? Is everybody okay if I don't do this? I really don't care that much about the error. Errors are neat. There's a whole thing about remainder and errors, and they're neat. But they're not the most interesting things. Okay. All right. Well, the one really cool thing about the error formula is you can see directly how picking more subintervals makes the error smaller. Yes?
Yeah.
I mean, we kind of know that's going to happen, but we actually see the mathematical dependence on the number of subintervals. And this is insane. If you pick a few more subintervals, your error goes to insanely small. It's crazy. Okay. All right. Does everybody feel okay about this section? It can be very trippy. The derivation of Simpson's rule is understandably trippy. I'm not going to make you memorize these. Do you understand? Primarily because I don't have them memorized either. So I never make you memorize things I don't have memorized myself. It's sort of like the nice PE teacher that doesn't make you do more push-ups than I can do myself. Okay. Out of paper, that sucks. Use some here. Okay. So the last thing for today. What time is it? Okay. So the one thing we haven't talked about so far, and I'm going to start with a nifty example. What happens to integrals in two situations where infinity shows up? One situation is like this. Now, anybody have an immediate reaction to this? I'm letting x go to infinity. So what does it feel like the integral should become?
The limit.
But I mean, just not technical. Just give me a number. What do you think it's going to go to? It feels like it should go to infinity, correct? Here's the trick, though. I'm going to bring this back later when we get to chapter 11, because believe it or not, this is very related to what we're going to do in chapter 11. In fact, I'm going to come back exactly to this later when we get to chapter 11. If I add an infinite number of numbers, what do you think is going to happen? For example, 1 plus 2 plus 3 plus 4 plus 5 plus 6. If I add an infinite number of numbers, what's going to happen? And notice I said numbers. I didn't say whole numbers.
Oh.
So, let me give you the most easy example. What if I add 0.1 to 0.01 to 0.001 to 0.0001? Do you all agree with me that all of those numbers, they never go to 0, right? And they're all positive, yes? So I'm adding an infinite number of non-zero positive numbers, which I know is redundant, I don't care. And I also am cool with it. You guys kind of with me? What is the answer there?
0.
Can't be 0, because immediately it's more than 0 right at the beginning.
One.
Not what's the limit of the numbers, but what is the sum? Does anyone know what the sum is? Yeah, 1/9. The sum is 1/9. 0.1111111, yes?
Yeah.
So, very quickly, when you first hear somebody say, I'm going to add an infinite number of numbers, you might go to whole numbers. Even if you don't go to whole numbers, you still feel like it should go to infinity. I'm sorry, you have a... Go ahead. Go for it.
Isn't this kind of like the same reasoning why we say to the power of 0 is 1?
No. Sorry, I'm trying to see if it relates, but not really. Sort of. No. This is more... I could stretch it to almost do something like you wanted to. This is more like 0.1 to the infinity, right? Because this is 0.1 squared, 0.1 cubed. Yeah? Okay, so it's kind of like the reverse of that. Yeah.
So
Yes.
you're talking about all numbers, could we say 0? Because if we get the 0 and then think about all of the other numbers, they cancel each other? Because we have the positive and then the negative, and they're all the same? No?
Start over again? How do you get negatives in? What are you doing?
Well, if we're just adding an infinite number, so we have all the negatives and positives and we cancel.
Oh, if you add all the known numbers on the number line,
Yeah?
it will be 0, sure. There's no, I'm being way too simplistic there. We'll get to that idea when we start doing integrals from like negative a to a,
Okay.
and negative infinity to infinity. Okay. Okay, so everybody understand now that I could add an infinite number of things and they could come out to be a finite number. In fact, a very, very small finite number. Real quick, do you got, anybody knew this? Did anybody know this fact? Okay, real quick, do you know this fact? What's 0.3 repeating? You know it.
1/3.
Okay, so what do I get when I divide this by 3? What do I get? 0.33 repeating divided by 3 is 0.11 repeating, and what's 1/3 divided by 3? Yeah, okay, so you know 0.111 is 1/9.
Yeah.
So what's 0.222 repeating? 2/9. Okay. Blah, 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 blah.
Yeah.
Okay. So how the shit do I do this? Somebody had a very good idea here. I cannot, dear God, if your Calc 1 teacher didn't make a big enough deal out of this, I am making a big deal out of it right now. This is going to hurt me. This is going to physically hurt me. If I ever see shit like this, I'm going to need you the next day I see you to bring infinity to me. Is everybody with me? You cannot plug a process into a function, because that's what infinity is. Infinity ate a number. I had somebody that just couldn't stop doing that, so I told them put BFN, which stands for big freaking number. You with me? Because that is at least a number, and it captures the idea that infinity is letting something get really big. It's not a number. Okay. So don't be plugging infinity in. Since I can't plug infinity in, and the way to do an integral is get the antiderivative and plug the shit in, what do I do?
Take the 30
To make Jeff happy. Weird guy.
The 30 and then do the limit to...
Limit. I immediately rewrite this as the limit as t goes to infinity. 1 to t.
Okay.
How's everybody doing? You have to rewrite it so that if I kind of cover this, there's not a damn problem with that interval. Nothing. T is a number I don't know, so it's just a number. I can plug it in. Then I'm going to let that go to infinity. Everything's kosher. We're all happy, including me, which is really important. So with that, my happiness is utmost importance. So what is the integral of this? What's the antiderivative?
Negative x. 1 over x.
Good. And I want to go from 1 to t. Is everybody cool? So then I get negative 1 over t minus negative 1 over 1. What's this go to?
0.
So the answer is
1.
1. You guys with me? It's basically what just happened is the same thing that happened with 0.1 plus 0.01. What I'd like to say is, all right, look, when you plug a 1 in, what do you get? 1. When you plug a 2 in, what do you get? Which tells me something went wrong. Let me think about it for a second. I feel like something went wrong. I'll be all right. What did I do wrong?
I don't think anything wrong.
I must have. I'll have to think about it. But okay, the form is fine. I just feel like I must have done something wrong because what do you get when you plug a 1 in? 1. Oh, that's fine. I'm not thinking correctly. It's the area, Jeff, so I'm good.
Okay.
The area of the first little rectangle would be less than 1. I'm good. The function value is 1, but if I look at the area, this is going down.
Yeah.
This area is less than 1. Okay. So when I add up all the areas, I get 1.
Yeah.
I was just being overly critical of myself. 1 over x squared is like, when I plug a 2 and I get 1/4, 3 and I get 1/9. They're all, I like to say, they're all getting out of their own way quick enough. 0.1 plus 0.01, do you see how there's no overlap? So there's no way that I could crank, the number is never adding to itself. It's always getting out of its own way. So let's do this. Can you guys do exactly what I just did, but do it to this integral? Yeah,
I'm trying to understand why improper integrals are the last section for sequence and series.
Oh, yeah.
Trying to-
Because there's so many connections.
Yeah.
And I can immediately go back and go, remember what we did? Same shit. And then we do integral tests. It's like, oh, okay.
Changing it to a limit, making up a variable,
Great.
and then integrating, and then fundamental, theorem. Okay.
Not sure why I'm
This is a T.
rushing. Okay, you get plenty of time. So let me try to catch up to you guys. Infinity freaks us out, so we take it out of the way for a second. Put all of it over here so we can worry about it later. What's the integral of 1 over x? In general, is actually like absolute value. My inputs
Yeah,
are positive, so
absolute
screw the absolute value.
Okay.
From 1 to t. So natural log of t. And then natural log of 1 is
0.
good. And what happens here? What's natural log do as the input goes to infinity?
Diverges.
It goes to infinity, which we do say that it diverges. So if an integral comes out to be a finite number, we say that it converges to something. If an integral comes out to be some kind of infinity, it diverges. Just to lay down some terminology. I'm pretty sure this section uses that terminology.
It does.
Chapter 11, it definitely rules the day. The idea of convergent versus divergent. So what this means is, if I look at the associated sequence, this would be 1 plus a half, plus a third, plus a fourth, yes?
Yes.
That series, which is just the addition of sequence elements, doesn't get out of its own way. Believe it or not, that goes to infinity. That diverges. That's a little trippy, because 1/3, 1/4, that feels like it's getting pretty small. But if you keep going forever, it actually accumulates and eventually pushes itself to infinity. And the really funny thing is, it's on a knife's edge. If it's very cool with what did integral 1 over x squared do?
It converges.
Converged. What did integral of 1 over x do? Diverge. Here's what's really, really trippy. The integral of 1 over x to the 1.00000000001 will converge. But the integral of 1 over x to the 1 diverges. It's so desperately neat. 1 over x squared definitely diverged. So then a good question, if 1 over x to the first diverges, I'm sorry, did I say that wrong? 1 over x to the first diverges, while 1 over x squared converges, you go, well, is there a number between 1 and 2? where it kind of like changes? Do you understand what that? Because I can do 1 over x to the 1.5. I can do 1 over x to the 1.1. And what's supremely trippy is if it's greater than 1 at all, the power, it converges. If it's 1 or less, it diverges. Trippy. Okay, maybe you guys are with me. So what's it mean for an integral to diverge?
It goes to
The answer is some kind of infinity. Yes? Converges means it's just some finite number. Okay. The other form, by the way, I haven't given this idea a title. These are improper integrals.
You want to type 1, right?
They're integrals that wore white after Labor Day or something. Yes? Sorry?
Oh, the type 1, right?
Sorry?
Oh, the type 1, right?
Oh, yeah, the different types of improper. I almost don't care. Yes.
You want
So when it
to-
comes to the integral from 1 to infinity, if it's x cubed over, sorry, x squared over x cubed, is that divergent because of the?
Totally. It depends on, so even if I had, for example, what do you guys think?
oh, same.
Divergence.
From like 1 to infinity. That's going to diverge because it's effectively 1 over x. Yes?
Yeah.
You could do u7 blah blah blah, right? And it will diverge. So anything that the degree of the top and the degree of the bottom are off by 1, where the bottom's bigger, well, if the top's bigger, it's obviously going to go to infinity, but you kind of with me? If it reduces to 1 over x, if you ignore all the lower degree shit, then it's going to diverge. In fact, that's part of what we're going to learn in chapter 11. We'll talk about it. I don't want to talk too much about that yet. So the other kind of improper integral that I'm just going to introduce, and then we'll focus on it next time. I had an interesting one. Oh yeah, it was on the other side of that paper I gave out. Yeah, look at number 2 there. Should I do that one? Damn it. No, I don't want to. I want to point out something though. Why is this an improper integral? Why would that be? Does it have infinity in the limit? Obviously not. But it's some other type of improper integral. When you plug a 0 into the function that's inside, what happens?
You get an error on the bottom.
No, if you plug a 0 in, you get 1. Right? You guys see that? Because cosine of 0 is 1, sine of 0 is 0, you get 1. What do you get when you plug a pi over 6 in? What's sine of pi over 6?
1/2.
Yes, because sine likes y, pi over 6 is far away from y, sine is scared, it's 1/2. Yes? What's 1/2 times 2? 1. 1 minus 1, 0. So what happens at pi over 6? When I plug pi over 6 in, I get, we're at 3 over 2 over 0. I get a type of infinity. Yes? So this is the other type of improper integral. Either has an infinity directly in the limits, or has an infinity that comes out somewhere in the limits, right? In this case, it happened at one of the endpoints. It could happen in the middle of the range we're looking at. Now, what I want you to realize, we'll do this problem next time, but what I want you to realize, we just figured out a minute ago that 1 over x squared, this area was finite. In fact, it's smaller than you might think. It's crazy. So, what kind of thing do I have on this problem? I have an asymptote. I have an asymptote at pi over 6, yes? What was it going from to again?
From
0, okay. So at pi over 6, I have this asymptote. Wow! But do you see, couldn't this just be that turned around? So that's why if there's a possibility that this kind of issue comes out to have an answer, then this kind of issue could also have the kind of answer, because if I turn it, the area is the same damn thing. So it's not surprising that this might have you can do it, Jeff, a finite answer. Because of that, it could kind of get close to the asymptote fast enough that as they accumulate area, it doesn't overlap. I really hope that makes sense. It's not like 0.1 plus 0.01, it gets out of its own way. I like to say that a lot. Well, I'm going to say that a lot when we get to chapter 11. Does it get out of its own way fast enough? Okay. Which is a generally good life lesson. Get out of your own way. All right. I think I'm going to let us out. The earliest I've let us out in a long time. Just because. Y'all deserve it. Yeah, I mean, you just listen to me. I'm sorry about that. So on Thursday, I'll have the practice test. We'll finish up 7-8. I'll have a little group worksheet to go over some 7-8 stuff. What's up?
No, it's just so cool.
I know. This is so, I agree. I'm gonna do some lip service to, I mean, it gets really cool when we do negative infinity to infinity. And there's like a different type of integral that will allow an answer, and the traditional type of integral won't. And I agree with the alternate version, because the traditional integral has to start at negative infinity and go, whereas another type starts at 0, goes out. So if you have this function to kind of like sine, like it cancels itself out, the answer should be 0, but traditionally there's no answer because it's stupid. Yeah. So we'll see.
Are we doing the practice test here, or is it like a handout?
Do it again.
Are we
Oh.
doing the practice test here, or is it
You don't ever, you can, the minute I give it to you, you can make it into a paper airplane and throw it away.
so
It's just a study guide, and I'm gonna have the answer key the following class. Yeah.